So if you want to test the ammonia gas, so what you can do, uh, you can test with a red litmus paper. The red litmus paper will turn blue. These are the tests for the gases. If you want to test carbon dioxide, we'll add a lime water and the lime water will turn milky. If you want to test a chlorine gas, you can test with a damp litmus. So we'll test with a blue litmus paper. First it will turn red and then it will bleach. If you want to test hydrogen, so hydrogen with a lighted splint. So a lighted splint will pop, like it will produce a pop sound. And if you want to test oxygen, glowing splint. So these are the tests for the gases. If we test ammonia, it will red litmus turn blue. If carbon dioxide, it turn lime water milky, and chlorine will bleach the litmus. If you want to test oxygen, so the glowing splint will relight or rekindle. And lighted splint is there. If a lighted splint, what it will produce a pop sound. So these are the tests basically you have to learn for ammonia, carbon dioxide, chlorine, hydrogen, and oxygen. I will show a demonstration, a video in which you will see all the tests again. The first one is, test one is oxygen. So if a gas jar contain oxygen, you can see the glowing split relight. And why the glowing split relight? Because oxygen support burning. Oxygen help in a burning or support combustion. That's why if we have a glowing split, it will relight. If you want to test a hydrogen gas, so hydrogen gas is produced when acid react with metal. So this is a lighted splint, and what you will observe, a lighted splint will produce a pop sound. The sound you may not be able to hear right now, but what happened, it pops sound because hydrogen also burned. Hydrogen is a flammable, so it can burn as well. So this is the second one, is a test for hydrogen. If you want to test, if you want to, yeah, this is about the hydrogen. If there is a lighted splint, what we will see, observe pop sound. So if we want to test the carbon dioxide, this is a test for carbon dioxide. So you can see some marble chips are shown here. These marble chips, when they react with acid, it gives carbon dioxide. Bubbles phase, the gas is given out. And what will happen when this gas, we will pass this gas through a lime water. So when the carbon dioxide is passed through a lime water, what we will observe? We'll observe the lime water will turn milky or chalky. You can see here the lime water initially was colorless, but it turned milky. So this shows the presence of carbon dioxide. This is all about memorization. You have to memorize all these tests. So whenever we want to test carbon dioxide, we will always test with the lime water, and lime water will turn milky. Is it clear till this point? So this is a test for the chlorine, but first we produce chlorine gas. How we produce chlorine gas? So first we do electrolysis, and when we carry out the electrolysis, sodium ions, a hydrogen ion will move towards cathode, and chlorine ion will move towards anode. And this chlorine gas, after electrolysis, so chlorine gas is produced, and now if you want to test a chlorine gas, first he's producing. You don't have to learn the production here. So a chlorine gas is given off. How we can test the presence of the chlorine gas? So as you can see bubbles here, the bubbles are representing the gas is given off. So we'll test this with a blue litmus paper. So a damp blue litmus paper is there. When we place this litmus to a chlorine gas will turn this blue litmus first red, and then it bleaches. So when it bleaches, it means that the color is disappeared. So this is a test for chlorine. So these are the litmus paper. These are the litmus. This is a litmus paper which changes the color. So now some questions related to this part. As you can see, this is electrolysis. This is electrolysis exercise 3. That was the last week homework. So most of the questions, almost all of the questions are from alternative to practical or ATP. The diagram shows the apparatus used to electrolyze sulfuric acid. So this apparatus is used to electrolyze sulfuric acid by passing a current through a sulfuric acid. What happened? When we do electrolysis, in this case, one side hydrogen is produced, another side oxygen is produced. Complete the box to show the role of platinum. What is the purpose of the platinum? Why we use platinum here? So platinum is used as a electrode. Give one observation during this electrolysis. So what is the observation? Whenever hydrogen or oxygen gases are there, so what you will observe? You will observe bubbles. So we'll see bubbles, or we'll observe bubbles, and the bubbles are basically shows that gases are given off during electrolysis. The next part, compare the volume of oxygen and hydrogen. So when we compare the volume of oxygen and hydrogen, as you can see, this amount of hydrogen given off is more than amount of oxygen, and comparison is there. So when you compare something, you use the ratios. So what it appeared that amount of hydrogen is twice as compared to amount of oxygen. So when we compare the volume, the first thing we'll write amount of hydrogen is more than oxygen, and when we compare, it is about, so it is in a ratio of 2:1. So amount of hydrogen is twice or as compared to amount of oxygen. Then which substance break down to form these gases? So which substance break down to form hydrogen and oxygen? The oxygen gas is produced when hydroxide ion move there, and hydrogen gas is produced when hydrogen ion is moved towards the electrode. So what happened when hydroxide ion move towards The anode, oxygen is produced. When hydrogen ion is moved towards cathode, hydrogen is produced. So the question is, which substance break to form hydrogen and oxygen gas? So hydrogen ion and hydroxide ion are there, and when hydrogen ion and hydroxide ions are there, it means which substance break down to form these gases? That is water, because H and OH will give water or H2O. Then give one test to distinguish between oxygen and hydrogen. So the test which we can use, we have to write only one test which can be used to distinguish between hydrogen and oxygen. So for, if we write lighted splint, because the lighted splint is a test for hydrogen. So lighted splint, it will give a pop sound with hydrogen, and there will be no result or no change for oxygen. Is it clear? The first question, the page 2, the first question. Anyone having a doubt in first page? Any question or doubt from page 1? Then moving on to the page 2, we have a metal ring, and we want to coat this metal ring by a layer of copper. So we want a copper plating. So if we want a copper plating, like example, there is a ring and we want a layer of copper. So the anode should be made up of copper. The anode should be made up of copper, Cu. The ring is the object that is connected to the negative terminal or cathode. And the electrolyte should be a aqueous copper nitrate or copper sulfate. So when electrolyte is aqueous copper nitrate or copper sulfate, there's a copper ion, sulfate ion, hydrogen ion, and hydroxide ion. So what happened? Copper ion is less reactive, so copper ion will move towards cathode, and that copper ion will turn into copper atom, and it will stick to this cathode. So there will be a layer of copper on the ring. And what happened? Anode is made up of copper. So the copper atom from the anode will go inside the solution as a copper ion. This is what happened. If we want electroplating, the anode should be made up of the metal, which we want a layer. The cathode is made up of the object, and the electrolyte should be a salt. So how we write this answer? This is the explanation, the diagram, the label diagram. Then how we write this answer? We'll take electrolyte as copper sulfate. Then connect the positive terminal of the battery with copper rod. Then we'll connect the negative terminal with the ring. So we'll take aqueous copper 2 sulfate as electrolyte. we'll connect the positive terminal with copper rod, connect the negative terminal with a ring, and then we'll pass the current. So when we pass the current, the copper ion will move towards the cathode or towards the ring. And then at the last, what we do, we will rotate why we normally rotate the object, so that it will have a uniform layer. So we'll rotate the ring and remove, then dry. So this is what you have. You don't have to show how ions will move, because this is an alternative to practical ATP. So when it is ATP or alternative to practical, you don't have to write the equations here until unless they ask. Is it clear? Question 2, that how a metal ring can have a copper layer or a copper plating. The next one, lead 2 bromide is placed in a tube and connected to electrical circuit as shown. Lead 2 bromide is heated until it is molten. So we have molten lead 2 bromide. Molten does not contain water, so it contains lead 2 ion, and it contains bromide ion. So lead ion will move towards cathode, it's a positive ion, and bromide ion will move towards anode. Lead 2 bromide was heated until molten. A brown gas is given off. So there's a brown gas which is given off. State one other expected observation. The brown gas is because when bromide ion will move towards the anode, bromide ion will lose one electron, change to bromine atom. When two bromide ions are there, they will lose two electron and form bromine molecule. And this bromine is brown vapors. But when lead will move towards cathode, the lead ion will take two electron and it turn into a lead atom. And when metal is formed, so what we'll observe or what we'll see? We'll see a solid formed at electrode. Or there is also another observation. You can see a bulb is there. So when you pass the current through the solution, the lamp or the bulb will light up. So when the lamp or the bulb light up, it shows that the electricity is passing through this lead. Suggest a suitable material for electrode. Indicate on the diagram the negative electrode. So what is a suitable material? We can use the electrode either made up of graphite or platinum. Indicate on the diagram the negative electrode or cathode. So on the diagram, which one is cathode? The one which is connected with the negative terminal. So this one is a cathode. Name the brown gas at which electrode it given off. So brown gas, because bromide ion turn into bromine molecule and that will move towards the anode. So we will name the brown gas. So what is the brown gas? That is bromine, and it will be collected at anode. Why this experiment is carried out in a fume cupboard? When toxic gases are there, for the safety purpose. So when toxic gases or vapors are there, we always, for the safety purpose, we always carry it out in fume cupboard. So you can mention bromine is toxic or bromine vapors are toxic. Question 4. The diagram shows operators used to find the effect of an electric current on the concentration of aqueous solution of sodium chloride. On the diagram, label the electrode. So the one which is connected with the positive terminal of the battery, that is anode, and the other one is cathode. Give three observations, three things what we will see or observe, because this is concentrated aqueous sodium chloride. So concentrated aqueous sodium chloride, so it contains sodium ion, chloride ion, hydrogen ion and hydroxide. For positive ion, we check the reactivity. So hydrogen is less reactive, so hydrogen will move towards cathode. So hydrogen will discharge or it will move towards cathode. For negative ion, we check the amount. We have chloride and hydroxide. So concentrated means more Cl is there, because the term concentrated means more salt, and less water, so less OH. So chlorine gas will be there. So chlorine gas will move towards anode. So when chlorine gas will move towards anode, the color of the chlorine gas, that is yellowish green gas. So we'll say yellowish green gas will be there. At cathode, hydrogen will be there. So hydrogen is a colorless gas. And because there is a bulb connected here, so when you pass the current, the lamp will light up. So what are the three observations? So there is a yellowish green gas at anode. Hydrogen is there, which is colorless. So whenever colorless gas is there, so we can say bubbles at cathode. And what about the third one? It's the lamp will light up. Name the product at positive electrode or anode. So what product is there at positive electrode? That is a chlorine. And state the test for this product. What is the test for chlorine? So it is a damp blue litmus. And what will happen? It will bleach. That is a test for chlorine. Whenever there is a damp blue litmus, it will turn first red and then it bleaches. So you can directly write bleach. In question 5, the diagram shows the effect of passing electricity through hydrochloric acid, concentrated. So if you are passing the current through concentrated hydrochloric acid, the ions which we have here, there is a hydrogen ion, chloride ion, and hydrogen ion and hydroxide. Because it is a concentrated, so we have more Cl, so chlorine will move towards anode and hydrogen ion will move towards cathode. Label the diagram by completing the boxes. So this is an electrolyte or concentrated HCl, you can say HCl concentrated. These are the test tubes, and this one is when both are labeled, so it means it is electrode. Name this process. So what we call this process, we call that as electrolysis. Give a test for chlorine. So what is the test for chlorine gas? The test for the chlorine gas, it is a damp litmus, damp blue litmus, and the result it bleach. Then another question, concentrated hydrochloric acid is electrolyzed. So when concentrated hydrochloric acid is electrolyzed, so HCl and HNOH. So hydrogen ion will move towards cathode, and chloride ion, because it is more, it is concentrated, so it will move towards anode. Label the position of electrodes. So one is the one which is connected with a positive terminal is anode, and the one which is connected with a negative terminal is cathode. Give two observations whenever hydrogen and chlorine gases are there. So at the negative there will be hydrogen gas, so colorless gas, and you will say colorless gas or bubbles are there at. And whenever lamp is connected, you can also mention lamp light up. So give two observation. So the lamp light up and there is a colorless gas or bubbles. Name the product at positive electrode. So because chloride ion is there, we have H plus, Cl minus, H and OH. So this chloride ion will move towards the positive electrode. So that is chlorine. State a test for this product. So what is a test? It is a damp. Yes, you can also mention here. You can also mention a green gas, yellowish green gas. That is acceptable. So the test is the damp blue litmus. And what is the observation? It will bleach. So these are the tests for the gases which you have to learn. Is it clear? This was exercise 3 related to topic electrolysis.